Okay, so we talked about object-oriented programming and about setting up classes in our Python programs. You've had a bit of a practice of that, and you'll get lots more practice to do that, as I say. Another thing that's quite useful is the concept of inheritance. You've already seen a little aspect of the concept of inheritance when we talked about instantiating objects from classes, in that the instantiated objects inherit the attributes and methods of the class. Now, we can actually take that concept a little further and do something quite useful. So let's think back to our example before, where we had a class called vehicle. And then from that, we created various different types of vehicles. So we had like an ambulance, car, monster truck, etc. However, what if you actually wanted a class called ambulance and a class called car, etc., and that you wanted to create objects from those classes? Now, what we could do, one way around that, is to create a class called ambulance and put in all the things, all the methods and attributes of ambulances, and then create a class called car and do the same for that, and a class called monster truck and do the same for that, and that would be fine. But as you'll have seen already from thinking through this example, there are lots and lots of things that are common to ambulances and to cars and to monster trucks, common between all these things, because they're all examples of vehicles, and hence why we've used vehicle as the class so far. So one way around this is, what we could do is still to create a class called vehicle, but then we could create a subclass called ambulance. And what we can, the advantage of doing that, and so we then create objects from the ambulance class. Now you might think, what's the point of that? Isn't that double the workload? The beauty of doing this is that we can set up a class called vehicle, in which we set up all of the things that are common to vehicles. Then we can set up a class called ambulance that inherits from the parent class. So vehicle would become the parent class, and ambulance would become the child class. And what this allows us to do is to create a new class called ambulance. But rather than having to retype everything that is common to all vehicles anyway, we can say that ambulance is a type of vehicle. So grab everything I've already said about vehicles, and then we can just focus on the changes we need to make to ambulances, things that are specific to ambulances. So maybe, a method to turn your siren on and off, and an attribute to indicate whether your siren is on and off, for example. The same with cars. We might say, well, cars have lots in common with lots of other vehicles, but we may have some stuff that's unique to cars. And so we can just say a car class is inherits from the vehicle class, and it takes all of that stuff I've already said about, but I'm also going to just make these few minor changes as well. And we can do that really easily in Python. I'm just going to quickly show you how to do that. Oh, sorry, I didn't mention that. Okay, so as I say, this is called inheritance. So if we think about the example we've just looked at, creating an ambulance class, almost like a subcategory of vehicle. So we may have vehicle, which has a number of wheels and capacities, its attributes, and a method to drive, and that describes all vehicles. That could be the parent. And we can say, okay, we'll set up a new class called ambulance, and that's going to inherit those things from vehicle, but it's also going to add on a couple of its own. So in this case, we can say ambulance is a type of vehicle, but it's also got a Boolean attribute that indicates whether the siren's on or not, and a couple of methods telling it to turn on the siren and turn off the siren. Okay. Now, fortunately, it's really easy to do this in Python. So here I've set up my vehicle class exactly the same way as I did before. So with number of wheels, capacity, and owner, and then set up my drive method here. But let's say now I want to create a new class called ambulance, but that inherits all of the features of the vehicle class. So I do this by simply declaring a class in the normal way. So I'm calling the class keyword and then using the name I want to give it. So ambulance here. But I pass in the parent, the class that I want to inherit from. So in this case, vehicle. I want ambulance to be a child of vehicle. So I simply use open brackets and then the class name I want to inherit from, and then close my brackets. And then I write my class in the normal way. Now, the beauty of this is that, so in vehicle, we had to set up the constructor to say, here's the number of wheels, here's the capacity, here's the owner, here's the attributes, etc. There's a really convenient shortcut that we can do all that in Python by just saying, grab all that stuff, do all that stuff you'd normally do for the in setting up the vehicle, but also do this. And the way we do that is we can use the super function. The super will, so we've already seen that self kind of refers to the instantiated object. Super goes in the other direction. It refers upwards to the parent. So this super, if I say super and then open and close brackets dot, and then I call the constructor method, the dunder init method here, and I pass it the number of wheels, capacity, and owner. This will say run that constructor in vehicle. Do that. I don't need to type all that out again. Just do that in the parent. And then for anything I want to add on, I can say if I want a new attribute for ambulances that says whether the siren's on or not, I'll just do that here. So the super allows us in one line of code to say, do all that stuff, set it up as though you're setting up a vehicle using the parent constructor, in this case, the vehicle constructor. And then if I want anything else, I'll add it on here. So that allows us to not have to type all this. Now, obviously, there's only 3 lines of code here, so it's not particularly onerous. But if you were doing a much more complex class that potentially had tens or even hundreds of attributes, that becomes a very, very convenient shortcut that we can just call the super function to say, call the parent class's constructor, do its thing, and then if there's anything else I want, I'll include it here. We can still set up methods in the normal way. So if we've got new methods, which we said we wanted to turn on siren and turn off siren, so I'd set those up exactly as I did before. Or we can overwrite a method as well. So let's say I wanted to overwrite the drive method of vehicle to say actually the drive method is going to be slightly different for an ambulance. So I can just give it exactly the same name as the parent. So if I define drive here, and by using that same name that I've used for the parent, I can then overwrite this, and then it'll use this method for drive instead of the parent. If I didn't declare that at all, then it would just use the drive method here. So you may have hundreds and hundreds of methods, and you just need one that's slightly different. You can just declare that one to overwrite that, and everything else will be automatically inherited. So you don't have to write them all from scratch. So it's a really useful way in which you can it's all about reusability, essentially, that you're able to grab from a parent and say it's mostly a vehicle, it's mostly the generic vehicle, but there's a few extra things, a few extra bells and whistles that are unique to this, and that may be either new stuff in terms of extra things on top of the vehicle class, or it might be things that are slightly different, so like the drive method, which is a bit different for an ambulance. So if I were to run that, I could then declare an ambulance as an ambulance. I don't declare it as a vehicle. So I say my ambulance equals ambulance. I pass in the values as normal. And I've got an extra one here to indicate the siren, whether that's turned on. And then I can call the method on the ambulance saying turn on siren, and I can call the drive method of the ambulance, and it'll run all of this as though it were part of the vehicle class, except with the new bits bolted on. So it's really useful, and you'll see later in some of Mike's stuff, as I say, that some examples of where you use inheritance. Something else just worth flagging up, it came up in a couple of the sessions I sat in on as well. Python allows us to really easily loop through objects. So I saw one group put print and then the name of the object. So in this case, for example, Mike's ambulance. and they were a bit confused because it came up with a slightly mysterious message. It just said object at, and then it gave this very long number. So Python is doing the right thing. Python is saying, okay, yes, I'll print that. It's an object at this memory address. That's probably not what you want. What you're probably doing is, if you're trying to print an object, probably what you're really wanting to do is print some attributes about the object. You're trying to get some information from that object. And we can do that, as you've seen, just by referencing the object using the dot notation. So if I wanted to grab the number of wheels on Mike's ambulance, I can say Mike's ambulance dot number of wheels, and that will give me the number of wheels. And we can also plonk all of those objects into a list, for example. So we can say I have a list of vehicles, and I put in Mike's ambulance, Sean's car, Alison's bicycle, and Tom's monster truck. And then I can loop through that list, and then I can ask, for example, here I do some conditional logic and say, if the common name of the vehicle in each item of the list is bike, then drive it at a random speed between this range and this range. Otherwise, drive it at one of these speeds, at a random speed between these limits. So this demonstrates that essentially you can treat your objects very much as objects that you can put into, in the same way that you built up lists with numbers and strings and variable names in them. You can put objects in a list as well, and loop through them and grab the attributes of those objects, or call methods on those objects, for example, as well. And another key advantage of all this, as I keep sort of banging on about, is the idea of reusability. And as I said earlier, it's not just about being able to reuse it within the same piece of code in the same program. We can write some code and then use it in a completely different program. And say, oh, actually, I wrote this thing that was really useful when I did my ED model over here. I could do that using that function again, because that does exactly what I need it to do. And so we can do that. And what we can do in Python, we can store a .py file that represents a module, which is multiple class definitions and functions, and then just import it elsewhere. And we can either import the whole thing, or it may be that we just need to grab one particular method, for example, from the module. Now, you've already been doing this and just not thinking about it, in terms of when you've imported the random library or imported other libraries that you use, like pandas and NumPy. Exactly the same principle. You're importing a module which contains class definitions and functions, and then you can use them somewhere else. Let's look at a quick example. So here I've got a file called pencordwizardry.py, and in this file, we've got this piece of code, which is a combination of a class. I've got a class definition in here, and also a standalone function outside of that class. So here I've got, so it uses the random library, and I've got a class defining a pencordian, which the constructor sets up, giving the pencordian a name and a boolean indicating whether they're a wizard or not. And then we've got a function called writeModel, which takes as an input a type of model, and then prints out a message saying whatever this pencordian's name is now writing whatever the type of model that's been passed in is model. And we've also got a method called tellJoke with a probability of success. And then, as before with the probability of cure that you did in the previous exercise, just takes a random number between 0 and 1, checks it against that threshold, and then says either they attempted to joke and people loved it, or they attempted to joke and it fell flat. So that's our class. That's a pencordian class. And then separate to that, I've also got this standalone function down here that I've called turn into a wizard. So I've got my turn into a wizard function, which takes as an input a subject. And I put in the comments that whatever subject is passed into this function has to be an object with a name string attribute and is a wizard boolean attribute. So a pencordian would be a pencordian object would be a valid object to pass into this function because it has both a name and is a wizard boolean. And all this does is it turns them into a wizard by setting the subject's is a wizard boolean to true, and then prints a message saying they're now a wizard. Okay, so that doesn't look too interesting at the moment, but now let's look what would happen. So we've got that stored in one Py file. Let's imagine I've gone on and I've started creating another program now. I've put this one in import code 1.py. These files, by the way, are available, so you can download these and have a look at them. I can't remember if I've put them up yet or not, but they will be up. So this is a completely separate file. Again, I'm importing the random library, but this time I'm also going to import penchord wizardry, which was the file that I created over here. Okay, so I'm going to import penchord wizardry. And then in this file, I've got a list of Penchordian names, and then I'm going to randomly select 3 Penchordian names. Little useful thing that we haven't shown you so far. There's another function of the random library called sample. Sample takes a number of elements from a list without replacement, i.e. they can't be repicked once they've been picked. There is another method called random.choices. If you use that, then you can pick the same value multiple times. But in this case, I want to pick 3 different names from this list. So I use random.sample on this list of names. So I'll pick 3 different Penchordian names. Then I'm going to set up a list, an empty list of Penchordians here. And then I'm going to loop through my list of chosen Penchordian names that I chose at random, my 3 names. And then I'm going to append to my empty list of Penchordians the Penchordian that's been chosen, their name, passed into the Penchord Wizardry Penchordian class. So let's unpick that. What it's actually doing is saying, grab the Penchordian class from the Penchord Wizardry file over here, which I've written previously. Because we've imported that, it knows what that is. So I can now refer to that other completely separate file by saying penchordwizardry.penchordian, and I can create a Penchordian with the name that I've selected. And then I can call a couple of the class methods on that, on these 3 newly created Penchordians. So I can loop through my new list of 3 Penchordians. I can tell them to write a model, specifically a discrete event simulation model, and I can call the tell joke method with a probability of 0.1, which sounds about right for a Penchordian telling a joke. So if you run that, you can see the output would say, Martin's now writing a discrete event simulation model. He attempted a joke, it fell flat. Dan's writing a discrete event simulation model. Dan attempted a joke, people loved it. And Sean's now doing the same. He attempted a joke and it fell flat. I promise you, I didn't sit there until I got exactly the combination I wanted with me telling the best joke. Definitely wouldn't do that, so I could screenshot that.
Probabilities. Probabilities.
No, believe we're statistically working out how many times you ran that result.
It was worth it.
I was just figuring out how you fix the program to come up with that result rather than running it multiple times.
Fortunately, I think I only did it about 7 or 8 times, and
it was a brute force attempt, wasn't it?
Yes, it really was. But the whole point of this is to show you that. So here, I've got a completely separate program that I'm writing in a completely separate file, but I want to use the concept of a Penchordian. I want to create a Penchordian class, which I've already defined in a separate program. So I just import that module. I import Penchord Wizardry, and then rather than having to type in what a Penchordian is all over again, I can just now refer to that imported. And another example, so it might be that we just want to import not the whole thing, but just one particular aspect of that module. So it might be a particular class or a particular function. So here, I'm just going to, for this, again, a completely separate program, I'm going to, from Penchord Wizardry, just import turn into a wizard, which, if you remember, was this separate function that I wrote down there, the standalone function. And this standalone function basically takes an object. The object has to have 2 attributes, one of which has to be a name, which is a string, and the other has to be a Boolean called is a wizard. And I'm going to use that function, but for a totally different purpose, because it will do the same thing that I need over here. So here, I'm going to define a new class called HSMA with a constructor that sets up a name and sets is a wizard to false. I'm then going to create a new HSMA, which I've called my promising HSMA, and I've called him Gandalf. And I'm going to turn Gandalf, my HSMA, into a wizard using the function that I wrote in the other program, which was designed for another purpose, but it works for what we want here. So I can simply say turn into a wizard, because I can just refer to that function, because I've already said just import that function. So therefore I don't need to say pen called wizardry dot. I literally imported it as though I wrote that function in this program. I can call the turn into a wizard function, and I'll input my promising HSMA, and that'll work because all that function needs is an object that has a name and is a wizard attribute. So if I do that, Gandalf is now a wizard. So I've used that same function that I've written over there separately, and I've used it in a new piece of code for a different purpose in order to turn an HSMA into a wizard. Arguably what we are trying to do with all of you over the coming weeks. Great, okay, let's not have another lunch break. Any questions about any of that before we move on? No? I'd encourage you to have a look back through those notes, as I always say, it really is worth doing. But have a look back over those notes about inheritance, because it's actually, once you get your head around object-oriented programming, it's very easy to do inheritance, and it's really useful. And you'll use aspects of inheritance all the time, some more explicitly than others, but it's a really useful way in which you can reuse code. And the more and more code that you write, the more and more useful this is. As an example, so you could, the prime checker function you wrote this morning, you could then import that function into another completely different program where you needed to check whether it's a prime number or not. And you don't have to write that function again. You've already written it over here, and you can just call on that. So it's really useful.
Sorry, could I just ask a quick thing about functions again?
Yeah.
And I in the text I asked a question about, does a function have to return something, and the answer to that was no.
Yeah.
So when you're writing a function, you don't even have to put return, even if it's not returning anything. You don't have to have return at the end of the function to make that it understood that that is the end of the function. You can just leave it, and it will automatically, when it gets to the end, go back to where the function was called. Is that right?
Yes, there is an exception to that in a different type of function, which we will show you in a few weeks' time. But yes, for now, yeah, that's absolutely fine. You don't have to return.
Thank you.
Okay.
Can I just say, sorry, Dan, that for human readability, it's best never to miss out the return, because it just helps people sort of see clearly it's the end of the function, and they can see what's returned, if anything. So I'd encourage you to put it there.
Okay, thanks.
Thanks, Mike. Actually, that's probably a fair point if you're thinking in terms of readability. I mean, in reality, there aren't, most of the functions you write will probably return something anyway. But yes, you might make a good point that even though you don't have to, there is sometimes some value in just saying return, and even if it's not returning anything. But yeah, all little points of practice that you'll, as you get more experience in coding, you'll learn about these little conventions and stuff that just makes things a bit easier on the eye. Okay, so let's move on to something I would argue is probably a little bit lighter than what we've covered this morning, and that is MatPlotLib. And MatPlotLib is a great and well-used Python library to allow us to plot graphs. Now, of course, you could plot graphs elsewhere if you're exporting your data out to something else, but Python actually has these really nice built-in libraries such as MatPlotLib to allow us to do that. And of course, if you're developing a model, you're probably going to want your model to output some graphs at the end of the run, so you can analyze what's happening. So MatPlotLib comes in really handy for this kind of thing. Now, I'm just going to flag this up. I think this will make it a little easier for you guys who've not used MatPlotLib as much as some of the rest of us. Traditionally, MatPlotLib has had lots and lots of different ways of doing the same thing, which means that even within the team, I've noticed that we all use MatPlotLib slightly differently, which can be an absolute nightmare. But fortunately, very recently, MatPlotLib's developers are now recommending the one recommended way of doing that, and that's to use the object-oriented way of using MatPlotLib. Unfortunately, we've talked to you about object orientation this morning, so you're already used to that kind of structure. So that's what I'm going to teach you here, the recommended way, and I'd recommend that's the way you now use MatPlotLib moving forward. But I flagged that up because you may see older examples online of people using MatPlotLib, and you think that looks totally different to the way I'm using it. That's why. Okay, so you're using, or I'm teaching you what is currently the recommended way of doing things. So as always with any packages, libraries that we're going to use, we need to make the necessary imports at the start. Now, I've put down 2 import statements here. The first one basically imports all of MatPlotLib, and like pandas and NumPy, there is an alias convention for MatPlotLib, which is NPL, so you'd import MatPlotLib as NPL. You probably don't normally want to import the whole lot. However, when you're playing around with this and playing around with MatPlotLib in particular, and starting to learn it, it can be quite useful to do that. So normally that would be quite inefficient if you were doing your programs in the real world. We don't, as we discussed before, we don't tend to want to always import everything. But I would probably recommend, at least initially, you do that so that you're just importing the whole lot of MatPlotLib. And there's a cheat sheet, which I'll mention in a moment, which MatPlotLib supplies, and they actually recommend that on that cheat sheet as well. The one you'll most commonly use if you weren't importing the lot is importing PyPlot from MatPlotLib as PLT, and again, that's a standard alias. And that provides you with a MATLAB style plotting interface. That's where the matplot comes from. It's from MATLAB. So there are 2 objects in a MatPlotLib graph, if you're doing this in an object-oriented way, which you're going to be. You have a figure object. The figure object holds the graph, the plotting area, and you have an axes object. And an axes object represents a subplot within a figure. Now, most of the time, you'll probably just have one axes object. You may have multiple plots on the same graph, but you normally only have one subplot. But you may have, in some situations, certainly as you start to expand out and do some more advanced modeling, you may want to have lots of subplots within an overall plot. So you may have 4 different graphs, for example, either side by side, or 4 in different corners, etc. And if you did that, you'd need multiple axes objects. But just for now, we're just going to focus on having a single axes object. So let's start by plotting a basic line plot, a nice simple graph. Okay, so I've got the import statements at the top, and here I've got some data to plot. So I've called one of my data items X and the other Y, and they're both just lists. So X is just the numbers 1 to 10, and then Y is various numbers that I'm going to plot on the Y-axis, basically. Now, all I need to do to plot this as a line plot is to first of all create a figure object and an axes object, and then add the axes object as a subplot to the figure object. The way we do this is we give the name to the figure object. I'm going to call mine figure 1, and a name for my axes object. And as I say, in most cases, at least initially, you'll only be using 1, so I've just called mine AX. Now, you won't have seen this. I don't think you've seen this convention before, though I think somebody did mention it in one of the earlier sessions. You've already seen so far, normally when you perform an assignment of something, you say A equals whatever, B equals whatever. But you can actually assign to more than one thing at the same time. And that's essentially what we're doing here by using the comma. So we're assigning to both figure and ax, figure 1 and ax. And we do that using the subplots method of PyPlot, which remember we've referred to as PLT. So what that will do is it will grab us out a figure object and an axes object, and the axes object will become a subplot of this figure. So that line of code does it all for you, basically. That's also probably one of the most common lines of code you'll use in MatPlotLib. That will essentially say set up a new figure with one axes object, and that will set that up for you. So then once we've got that set up, we just tell it to plot our data. And I call that on the axes object. Remember, the axes represents the subplot, even if we've just got one. So I call that by calling the plot method of the axes object. So I say ax.plot, ax.plot, and then I give it the data we want to plot, which here was just two lists of numbers, x and y. So here I say plot x against y. Now, if you just did that, nothing will happen, or nothing will appear to happen, because you need to tell it to show me the figure. So all we do that, we call that on the figure object, and we use the show method of the figure object. So we say, now you've plotted that, show me that figure. And if you're using Spider, that will pop up if you're using the newest version of Spider, which I think you all are. Then you saw back in one of the early sessions we showed you there's a separate plots tab in the top right that will allow you to click on plots rather than looking at your variables, and it'll show you all the plots that you're calling show on, and they'll appear there. So really simple. We're just doing the imports. We're setting up the data we want to plot. Then we create the figure and axes objects, and that single line of code does that for us. And then we plot the data. So we just use the plot method on the axes object to plot the data we want to plot. And then we use the show method on the figure object to show the figure. And that will then generate that rather nice looking figure. Now, that's pretty basic even for introductory standards. So let's imagine we want to add a few bells and whistles to this. Probably at the very least, you'd probably want some names to go on our X and Y axis, so that people understand what the graph is actually showing them, at the very least. And we can do that really easily. We can just use on the axes object, we could use the set_x label and set_y label methods in order to specify the label. So here I've said ax.setX label time and set the y label to number of patients. And if I do that before I call the plot method on the axes, then it will plot, and everything else is exactly the same as before. All I've added in. It will then plot that graph, but this time it's put on some labels on the axes, which is really useful for us. It might also be, for example, we want to change the color or style of the line, or both. And that's going to be particularly useful if we've got multiple lines on the same plot. But either way, we may want to specify a different color and or style. And we can do that, again, really easily by looking into the axes object. And this time, to change the color and or style, we can do that within the plot command. So before, we just, when we called the plot command, we just gave it the data we wanted to plot. But we can also add to that various attributes. So we can say, actually, make the color. I apologize, unfortunately, you do have to use the American spelling here, and it will trip you up the first few times. So here I'm going to specify color equals red, and you can also specify line style. And there's lots of different line styles. Again, the cheat sheet, which I'll show you in a second, has lots of these, so you can refer to them and see which ones you want to use. So here I'm going to use a dash line, which I use with 2 hyphens in inverted commas. So that will then, if I plot it in exactly the same way as before, that will plot exactly the same data, only this time the line is a red dashed line, essentially. Now, we've talked about putting in a single plot, but you may want to add multiple data plots within the same subplot, particularly if you're comparing things. So let's imagine in this example here that we've got some data we want to plot. On the x-axis, we want to plot time. I've just got the values 1 to 10. And then for the y-axis, we've got 2 separate plots. So we want to plot the number of patients in the clinic at any one time, and the number of doctors at any one clinic at any one time. So these may represent for example, days of the week. And so we're plotting numbers of patients and numbers of doctors, and we want to compare those on the same graph. So we do that in exactly the same way as before. Set up our figure and our axes. Set up our X and Y labels exactly the same way as we did before. And all we need to do to add in another plot is just to call the plot method again on the axes. Every time we call plot on the axes object, it'll add another plot. So here I've got an initial plot, which is going to represent my patients over time. So I'm going to plot time, which is my x-axis, against patients, my y-axis for that particular plot. I'm going to set my color to blue, although it would have defaulted to that anyway. I'm going to set my line style to the solid. Again, it would have defaulted to that, but sometimes if you've got more than one plot, it's worth spelling that out. But also I want to plot number of doctors over time on the same graph. So here I'm going to call exactly the same method again, only this time I'm going to plot time against doctors. And this, I want that plot to be red, the line color to be red. And I'm going to use this dotted line style, which I indicate with a colon. And then if I show that figure, you can see it's plotted both of these data series on the same plot. So really easy to do that. Literally, you just add in another another call to the plot method of the axes object. And you can do that as many times as you want, although for readability, don't do it too much, but as many times as you want on the same graph. Now, I bet you're sat there thinking, this is all well and good, Dan, but I live for legends. Where is the legend? Can I add a legend? Of course you can add a legend. And of course, it's really easy in MatPlotLib too. Particularly if we've got multiple data points, we're probably going to want a legend so we can indicate what these things are. So we can do that really easily. We simply do this in two positions. So we need to, for a legend, we need to do two things essentially. We need to tell it where to put the legend and that we want one. And we also need to indicate what label should be assigned to each of the plots. So in our example here, we're plotting patients and doctors on the same graph. So we probably want one of our lines to say patients and the other line to say doctors. So I can simply add the label argument here. Label equals whatever I want that particular line to represent. So for patients, I put in patients. And for doctors, I put label equals doctors. Now that alone won't do it. That'll just say, okay, I now know what the labels are. And should you wish to have a legend, I'll know what to say about these lines. But we need to explicitly tell it, and I want a legend, and I want it over here. And we do that simply by calling the legend method of the axes object. So here I say ax.legend, and into that I'm going to pass in where I want the legend, the loc, representing location. So I'm going to say loc equals upper left, and that will plonk it in the upper left form. So all I'm doing is just adding a label to my plot method as one of the inputs, whatever I want that label to say, and then calling the legend method on the axes object to say, I want a legend and here's where I want it. That's all very well. Perhaps you're sat there thinking, well, I don't mind a line plot, but my goodness, I'd much prefer a good bar chart. Well, that MatPlotLib has you covered in that regard as well. In fact, there are huge numbers of different plots that you can do in MatPlotLib. So let's look at an example of a bar chart. So here, exactly the same as before. I've got some data that I'm going to set up. So here I'm setting up the list of HSMA trainers and the numbers of their hours of teaching on the HSMA course. And then I set up the figure object and the axes object exactly the same as I did before. I'm going to set my X label and Y label exactly the same as I did before for my line plot. So trainer on the X-axis, that will represent on the X-axis to show the different trainers, and then the Y-axis to show the number of hours of teaching on the Y-axis here. And then the only difference is instead of saying ax.plot, which is what we did before, which gives me a line plot, I'm going to say ax.bar, and ax.bar will give me a bar chart. And I simply pass into ax.bar the X and Y data that I want to plot. So in this case, the list of HSMA trainers against the number of hours of teaching. I promise you, I'm not just trying to rub this in the face of my other HSMA trainers saying, look how much more I have to do than the rest of you. If you want to take that from this, then I can't stop you. But it was just the first example that spoke to my head. But anyway, exactly the same principle. So you can see I've done exactly the same as I did before. The only difference is I'm calling ax.bar instead of ax.plot to give me a bar chart instead of a line plot. We can do scatter plots. If you want scatter plots, I can give you scatter plots. So we can do scatter plots exactly the same way as before. Got some data to plot up here. One of them I've called A, one of them I've called B. I set up my figure object, an axes object, exactly the same way as before. I'm going to set my labels exactly the same way as before. Just call them variable A and variable B here. And you guessed it, instead of saying ax.plot or ax.bar, this time I'm going to say ax.scatter and give it the data I want to plot on my scatter plot. And that will do a scatter plot for you. So it's really easy to do lots and lots of different types of plots. And as I say, you don't have to worry about remembering all of this. I mean, firstly, there's vast amounts of information out there anyway, but MatPlotLib has a very convenient cheat sheet, and the cheat sheet is the up-to-date version which accommodates the object-oriented way of doing things, which is the way I'm teaching you here, which is the preferred method now. And it will show you all sorts of things about how you do certain types of graphs, set up certain styles of lines and graphs. And that cheat sheet it has been made available. I think I've already uploaded that. If not, I will upload it. I think it's already in your list of downloads. So do consult that, particularly when you're starting out, and it'll show you how to do all these different types of graphs. You can get different colors, how you're going to refer to different types of different colors, different positions for your legend, things you need to input for that. So that'll tell you how to do pretty much anything you want to do within MatPlotLib. Another really handy thing to do, as well as getting the figure to display on our screen, we may well want to save it for later use. Now, you can just in Spider, you can literally just copy and paste them somewhere else. So you can right click on the figure, select copy, or hit Control and C, and you can copy them somewhere else and save them in that way. But a better way of doing things is to save them in your code if you know you're going to need them for later. You don't want to have to be worrying about, did I remember to save my figures from that model that took me 2 days to run, and then realize you didn't. So always worth putting it in the code to make sure that happens. Probably do both, actually, just to be on the safe side. And we can save figures really easily by this single line of code here. We just call the save fig method of the figure object. In this case, my figure object is called figure1. And I say figure1.savefig, and then whatever I want to call it. And it will save that figure. So here I've just saved it as a PDF, and it will save that figure as a PDF for me. Okay. Time for you to have a practice at using MatPlotLib. And hopefully you've seen this is a much friendlier thing than some of the stuff that you've been doing up to now. It's quite nice to use MatPlotLib because it's pretty easy to do this. So what I want you to do is to write some code that plots a line plot comparison of hospital A and B mean ED attendances per day of week. So this is your data down here in this table. We've got average number of ED attendances by day of week for hospital A and hospital B. So I want you to plot a line plot comparison. I want you to use different colors or styles. You can pick whatever you want to use, and a legend to clearly differentiate the two lines on the plot and label each line appropriately, and also each axis. You should also force start the y-axis from 0. So by default, if you've got very high numbers and none of them are very low numbers, the y-axis won't start at 0. But in this case, I want you to do that, and we can do that quite simply in MatPlotLib using the set ylim method, and that's within the axes object, and we pass as an input ymin equals 0 as a parameter value, and no prizes for guessing. You could set that to whatever you like. So if you wanted your y-axis to start from 100, you could set y min equals 100, and your y-axis will be forced to start from 100. So by default, it'll be dynamic. It'll try and work out what it thinks is the best thing. So if you've got lots of numbers all in the thousands, it may be that you don't want to start your y-axis from 0, but you've got to be a bit careful, because it can also be a bit misleading if you're not starting your y-axis from 0, depending on what you're trying to show. So I flagged this up because it can be quite useful to force your y-axis to start at 0. So we just do that using the axes object and the set ylim method of the axes object, and into that, in the brackets, you'll just pass y min equals 0 to do that. Now, important note, you have to do this after you plot the data, not before. So after you've called the ax.plot method, but you have to do it before you show the figure. If you don't do it in that order, the y-axis won't resize correctly to the data. So you need to make sure that you do it after you've plotted the data, but before you show the figure. Once you've done that, once you've got your line plot, I want you to set up a new figure that plots on a bar chart the total mean ED attendances across both hospitals by day of week. So for Monday, that's the 242 plus the 310, etc. And do a bar chart showing total mean attendances across both hospitals per day of week. So I'm going to give you, let's have a look where we are. So I'm going to give you 30 minutes, I think, to do that. So we'll come back at 10 to 3. Feel free to work in your groups if you'd like to for this. If you'd rather do it on your own, that's fine. But if you are doing it on your own, do make sure that you're helping each other and still communicating. And the point was raised by someone in one of the peer support groups, and I think it's a very valid point to make. And it's certainly useful from us as mentors. I know a number of you have been doing this anyway. Even if you are working on stuff individually, it's probably still worth having a Zoom or Teams call open so that you can at least easily sort of talk to each other and share any problems, etc. So do make sure that you're at the very least using Slack to communicate, but ideally doing that, I think just having it on in the background just helps to pretend we're in the old days where we could sit in the same room as other people. Any questions about any of that? No? Great. In which case, we'll see you at 10 to 3. Have fun doing some plots. If you manage to do all that, by the way, have a look at the cheat sheet and see what else you can do with it. Great. See you in 30 minutes.